Ready? Action! Is this tutorial? It's more of a deep dive. I like doing research and I like diving into things to figure out what is all going on. You know, I'm calling this Godot secrets, but it's not really a secret. It's all available. The information is available in the document. Some people talk about it in different language, but the problem is that a lot of times, if you don't know what you're looking for, you wouldn't be able to find it. So my attempt here is to try and kind of unravel the mystery of everything that is Godot input. And some part of it is secret because some of it is not obvious even through the document. So we're going to do some experiments. We're going to actually write some codes down to see how the input chains are working and if it is true or not. If there's any bug, we'll be able to find it if there is a bug in the engine. So just follow along and enjoy the show. I'm pretty sure you guys already know how to use input in Godot. And there are a lot of videos out there already teaching you how to do simple input. And something that you might notice when using Godot and when you're looking at different videos, different tutorials, and even the documentation, there are so many different ways to handle input. Now, what do I mean by input? You probably know, but let's just get this baseline set up so everybody can follow along regardless of their skill level. Input is anything that you can use, anything that a player can use to interact with the game. That is mouse clicks, mouse movements, keyboard clicks, even the controller, game controller would be considered input. Mic is an input. So all these things are input, but the input that we're talking about specifically is general interaction like keyboard, controller, and mouse. First thing is the concept of what does the engine do when there is an input. At the base level, we want to do some critical thinking here, right? If you were to create your own game engine, I know we're going far, but just bear with me because this will all make sense. These type of information is relevant in making the best out of your game. And whenever you run into some issues that are not expected, this type of knowledge actually helps you debug your problem that is not something that you can search easily. So the first thing I think we need to understand is how you would handle input in a game. So we understand that game is a loop, right? So when you're seeing your characters move on screen, you see some sort of game logic that calculates what should show up next. And then you have the rendering logic where it shows what you queued up to show, right? So it is looping over and over again. And every frame, your screen changes based on the game logic. And this is called a basic game loop. Loop because we're looping. We know all that already. So if you were to handle input in this loop, how would you do it? Let's say this is a screen rendering, right? So you have a character where you have a character. It's a snapshot. It's just a picture. And you want to run a game logic first, some sort of code. Running this code will update the information about the game. Whether it's a player's health goes down or the enemy moves 1 pixel over, and then that information is updated, and then the information is translated into a graphic and maybe move the character on screen. So you have update of the data and then actually rendering. This is called rendering, where we translate the data into screen, rendering of the image based on the data. And basically you want to loop over and over again, right? So you're moving from here to here over and over again. And we call this a game loop. Now, if the player presses a button, for example, let's say this is a X key, and then the player presses the button. Okay, I'm going to try to draw convincing index finger here. Does it look like an index finger pressing it? When their player presses the button, an event is emitted, and that will try to interrupt the game loop. So this can go into any part of this logic, right? In between the update, or maybe even before the update. So how will we handle this? So we know there is a pending event that needs to be handled. There's 2 major different approaches that I'm looking for here, right? I mean, there may be more. The 2 things I'm looking for, one is event handling, which is immediately executed on the event. And then second one is polling. And they have places. So let's think about polling. What polling is that we have this event waiting in a queue, right? So we have key pressed. The event goes into some sort of queue, like a line, right? So we say, oh, X has been pressed and it's waiting. The next one will be here, next one will be here, and then it'll go out like this, right? And during the game update logic, the game logic can check the queue and see if there's any events that are waiting to be handled. And it'll be like, oh, hey, you know what? There is X that's waiting to be processed. So I'm going to process the X event. It'll take the key press event out and then say, hey, since X is pressed, for this case, maybe it's a jump, make the character begin the jump action. Anyway, so that's the long story. And there's some question to ask here. My question right now is that, so we know what the game loop is, right? In Godot, we have something called a process. So whenever we create a node and we attach a script, we know for a fact that there is a built-in function, process delta, that runs every frame, right? So process says, called during a processing step of the main loop. So main loop is a main game loop. And for each of the nodes, the function called process is executed. And here you can say, well, if the input blah, blah, blah is occurring, do blah, something else, right? And you've seen that method. That would be something like, that would look something like this, where I say, if input action just pressed, and then I say, you know, some UI accept, then, you know, right here, I could be like, do something. Sweet, right? I guess for our case, we can be like print event pressed. Event accept pressed. So what oh, I gotta save this. Let's save that as main, right? So in this case, this is the polling method where I'm sure a lot of you guys saw for character control, every game loop, this logic is checked. And it's a pressed action, right? And this is a just pressed action. So what we're expecting here, if we run this, let's do main. If you run this game right now, whenever I press accept, which by the way is spacebar, in the case of Godot, by default, you see action accept pressed, right? I'm going to try pressing it and holding it. It only executes once. Nothing happens. When I release it, nothing happens. And if I just snap a click, it also expresses it once. And you know, that's because this only evaluates true if the input has been just processed, right? What does that mean? So right here, look at this. It says, is action just pressed? Returns true when the user has started pressing. They started pressing the action in the current frame, or tick, right? The tick is one execution within a loop. So one loop execution. So this only comes as true. This is only true. Just press is only true if the key press happened right before this process code. So key press happened right here. It goes whoop, and then it's going to process it. And if you hold it down, even though next loop, it's going to be like, well, that key is still pressed. It's going to be like, it didn't get pressed this frame. It got pressed in the previous frame, so it's false, right? Which is useful because you don't want to repeat execute the key process. For example, if you're jumping, you don't want to have to jump infinitely, right? But another issue is that, let's say you're moving left or right, right? I mean, we can do that simply here. Let's create something. So let's create some sprite here so we can visualize it. I guess Godot icon is perfect example for this, huh? We got a Godot icon here. Let's say we move the icon position. By the way, this is not what you would normally do to move a character, but you know, this is what we're going to opt for. We're going to move the character by down right, diagonally. So let's say 1 pixel here, like that. Vector 2. Oops. So we're adding 1 pixel to the X and we're adding 1 pixel to Y. So we're expecting here, every time we press, the icon moves. But what if I just want to hold it down and have it move? It doesn't do that because it's only executing it once per press. So if we want continuous action, we want to do is action pressed. So alternatively, this one is true if the event is pressed, no matter when it got started. So if I restart this game now with that code, I can just simply hold it down. Boop, 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 right? But then the problem is that every press, because it depends on the frame rate, right? Depending on the computer, depending on the process, we don't really have a control over how often the underscore process is executed per loop, right? So if you have a slower computer, holding down the spacebar may move it slower. And this is a common problem. And this is kind of outside of the scope of this tutorial, this experiment. But normally what you would do is you would take delta, because in a single loop, the delta will show how many seconds has passed since last time it executed, right? So for example, in this example, let's say if the process code happened and then it took 100 milliseconds before coming back here, the delta in this case will be 0.1, right? Because 0.1 second is 100 millisecond. And so you can use that delta as an information to update the distance appropriately to a very fixed velocity. But that's, once again, outside of the scope. We can talk about that in other lessons. Today, it's all about the input. So cool. So we explored the polling of just doing the just action press and then the action press so that you can have continuous behavior. This is nice and all, but it's also kind of annoying, right? So we have this code that's checking for event on every loop. It's not that expensive right now. It could get expensive. This also means that your input is being handled on a loop only. What if you want to interrupt something very quickly? Like most of the cases, this works fine. But if you want to respond like UI, for example, if you want to click on something that are separate from the game logic and for that to do something immediately, you wouldn't normally want to do this. And also you don't want to bloat your game logic code because process is where you do like, the updated data of health or image updates or even like physics process. That's another process. So normally within a loop, you would calculate physics movement, all that stuff. And on top of it, you have these like input processing as well. Sometimes you need to do that, but it is also kind of bloating it. So there is a separate way to handle events. That is input handle functions. So each node in Godot comes with different functions, but there's a lot. I mean, that's the confusing part. That actually ends up being very, very confusing so let's say you don't do this. I don't do this. And instead I say, well, I'm going to implement a function called input. And this is also a built-in function just like process. So let's say we want to use underscore input function instead, right? So let's see what it says. It says it's called, right? It's called by the game logic when there is an input event. So this happens immediately, at least according to the documentation. So instead of, in this image, before when polling, we had the queue of input events and we're looking at it every loop manually as a developer. Instead, the game Godot, let me just quickly draw a little Godot. This is so bad, but you get the point. Godot will be like, ooh, there was an input event. I'm going to call input function for every single node that has input implemented. What does that mean? So that means if you have multiple nodes and multiple scripts, each one of them has script and they have input, it's going to execute this code, this particular code called underscore input. Let's test that out. Only thing is that it gets called for every input, right? So we can say input incoming. Let's look at it, right? So when we play this, look, if I move, you see how it's printing everything every time I move? You can see the log increasing right here. This is the number of logs, and this is the printout, right? Every time I move the mouse, it goes up. Pay attention to the number. I'm gonna click it. I'm gonna just press it down. Press a key down. You see that? It's calling the input because every input event causes this function to be called. That includes action of press, holding, and releasing, right? So once again, just like the polling process, you have to be very specific on what you want to handle, right? So you would do normally stuff like, oh, this is an input event, and I say, is action pressed? And UI accept, so this is what we're looking for, and say accept pressed. Let's see how that works. So we're looking at this down here. Once again, nothing's printing right now. I'm gonna do spacebar, down, and I'm holding it right now, and it doesn't execute multiple times. So it's broken down by press, hold, release, right? So how do we do hold? There's something called is echo, and that is right here, I think, is echo. Returns true if this input event is an echo event, only for events of type input event key. An echo event is repeated key event sent when the user is holding down the key. Any other event type returns false. We want to check print echo, right? So we can see now if we restart the game, I can press it and hold, echo, 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 echo. Now, if we want to be specific on, hey, I want to only be sensitive to the echo of a very specific key, I can say, hey, is it a UI accept action that's echoing? You can see, presses this, and then I'm going to hold it, echo, 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 right? And if I do any other key, so for example, if I do A, let me clear this out. If I do A press instead, nothing, it doesn't echo, right? So that's how you would detect hold. And then, of course, you have the release event where you can say, is action released? That's when you let go of the key. Basic stuff. I mean, I'm sure you guys all knew this already, part of it. But, just in case there's some of you that doesn't know this, the nuance of this, that's what we're going through. Echo, echo, and then released, right? Cool. Now, immediately you can see why you wouldn't use this for movement, right? Because from our experience, when we press an action, it only happens once, right? The moment that you press it. And you can't make it so that it's continuously consuming that event or understanding that that event is handled. You have to have the separate logic for echo. And that's kind of annoying. So a lot of the movement, character movement based like control are done on the polling, right? Because that's part of the game logic. But a lot of the interruption where you click once to make menu pop up, or you want to click on an event or click on an object to immediately switch to that window, then, that's what you want to use this interruption method for. Now, only problem is that this is not it. I mean, for like 80% of the use cases, these two things are only thing you need. But now, this is the promised juicy part. We're starting to get into the complicated, juicy part of the input handling. We're done with the basics. Right here, look at this drawing. This chart is kind of funny, right? This is a chart of the input flow within a viewport. And this kind of makes sense, right? So let me just take a look real quick. If I open a game, before we do deep dive, you can already tell why you might need this, right? Look, the window of the game is the game itself, right? So if I'm clicking on the frame and then moving it around, should the game, like the game logic itself, detect that or not? What's the hierarchy? By default, what should happen first? So this is us. This is a player. When they click or when they make the key press, it goes to the OS level. That's the operating system. And then it takes to the display server. And then immediately shows up here. This is where the input is beginning to be processed. And all of this down here explains it in a very repeated term. Basically, you see viewports function of a window manager, right? The window manager, the whole resizing and all that. And then it'll handle the focused window. If there's a multiple window, it's going to shoot the event into the focused window. And then it's going to shoot the event. If nothing gets consumed here, it's going to go to the next one, next one, next one, next one. So we have GUI event, input event, short key input event, unhandled key input event, unhandled input event, and then physics picking event. So many functions, so many functions. So in order to do this, I think better than Node, some of these events are exclusive to GUI components, which is control. That's what the control is for. Control is for key input a lot of times. So we have this control object. We're going to change this to control, which is the change type control. And we're going to actually detach this script and then create a new one. So let's say main control. So let's write down all the default input functions. So I'll be back. I'll just write down all the default functions in order, and then we'll start our experiment. This is where it gets kind of fun and interesting. All right, I'm back. Took me a while. There's a few things that's missing, but basically these are all the input handling. Also, for the fun of it, let's also write a process here, right? Because that's part of it too. Let's say delta float, and I'm going to say, let's see, if input action just pressed, and we're going to test with very specific input here, UI accept. Oops, I guess that reminds me, I should probably do it so that all the event is the same. So let me come back real quick again. All right, I'm back. I'm back. Okay. So you can see right here for each of the function, we got input, GUI input, on GUI input, which is actually a handler for the signal here. So another way that the input is triggered is there's a signal for GUI input for the control objects. And when the signal gets triggered, I can route it to a function, which I routed to this. There's a shortcut input, unhandled key input, unhandled input, and then a process. We're going to go into the play, and we're going to just press spacebar. There you go. So what do we got here? We got input function first. We got, oh, right. Okay, well, so the GUI input's not going to do anything because GUI input is specifically like focusing on an object and then interacting with it. And on ready, I use this grab focus function so that the entity that we're testing, which is invisible at this point, can grab focus so that some of these GUI inputs work. Let's try this out. So we start it. All right, it's empty. Now I'm going to just press enter or spacebar. Bam, you see it right here. Just as predicted, except these two are kind of flipped here. So if it matters, let me do it one more time to see if the order changes at all. And then one more time. So let's look at this right here. So I did a spacebar and it seems input, GUI input signal handler, GUI input function, shortcut, unhandled key input, unhandled input, and then polling in this order. And it seems like it's the same every time. So that's the order. So this order kind of matters. Now, they do the same thing. Essentially, they do the same thing. So why would you use different type of input in different ways, right? Doesn't matter. The fact is that you want these in a different grouping so you can handle that appropriately. So it's good to know these orders. Now, something that you probably noticed that is kind of annoying is that when I press it and a bunch of things happen, what if I don't want the input event to propagate all the way? Because right now, a single press is triggering input, GUI input, on GUI input, shortcut input, unhandled key input, unhandled input, and process. Actually, there's a way to consume input. And that is another thing that you need to worry about, because if you have multiple nodes, so if I copy and paste this, for example, additionally, just so that we are clear on what is being pressed, on the print, I'm going to include its name. It's a node's name, right? So let me come back after doing that to the script real quick. Do this. Okay, we're back. Now, when I press the key, you're going to see all the reports of which node is getting the input, right? So we see Control 2 got the input function, control got the input function, node got the input function, and then now the only node gets the GUI input, because why? That was the last thing that got ready, so it grabbed the focus. Everybody tried to grab focus, but then the root grabbed the focus last, so this is the only thing with the focus. So GUI input will only execute with the object that has a focus. And then you see control shortcut, control node 2D. So interesting, right? This seems to indicate that for each of the level in this input, right? So for example, right here, these are the level of inputs. For each level or each layer of input, all the nodes gets executed for that function first. It's not one node execute all the input logic, another node execute all the input logic. It does it in parallel. It executes things across the board and then move on to the next layer of input, which is fair, right? So that way, the whole reason we got into this, right, is because let's say I have the root node handling the main shortcut menu, and then the bottom one, the child node, handles a game logic. Then when I'm doing the game logic, I don't want to accidentally execute the shortcut event, right? So what I want to do here is that, for example, in this child event, if a key happens, right, in the input, then I don't want the shortcut to happen, right? So let's take a look at what that means, right? So as soon as the input is handled, we would do some sort of consuming action. You know, all these things are not very obvious. So if you look at the document, it actually shows what to call and how to handle this in each layer. So I'm going to read this real quick. So right here, this is how you would read this, right? For the input layer, it says if any function consumes the event, it can call set input as handled. So we got to call viewport set input as handled, executed. So what do? You do get viewport, and then I can say input handled, set as input handled, right? So now if I run this again, what happens? Okay, this is time for a little quiz. Okay, so we know from our experiment, the underscore input happens first. Now it happens first for all three objects. In this case, if we say, hey, let's make it so that the input is handled, meaning the input won't propagate down the chain anymore. If I press the spacebar now, what will happen? How many prints are we going to see? Got it? Well, let's see. It's like I'm pretending that I already know the answer, and then I'm like, do you know? But actually, I have no idea. I'm experimenting with you, so I actually learning myself. But you can see right here, look, control input function, control 2 got executed, but polling got executed for everyone. Very interesting. See, this is something that I didn't know. So when you're consuming the input, it consumes it for the input chain. It consumes it for the input command chain, but then the polling still is alive. Interesting. What if I handle it on polling then? So because polling executes later, what's going to happen here? Is that going to stop the further propagation of polling? Let's see. Uh-oh. You see that? Everything got executed, including the input, because polling happens at the end. Now we're thinking here. Every input handling within a node, it's per layer. So this got executed at the end anyways, so it's not gonna stop anything. But interesting information, little experiment. But the point is this right here. So we have this, boom. Input function only control 2. This one got executed first. We're going to talk about why that's the case. Actually, you can predict which one gets executed first. Did you think that the node 2D is going to execute first? Well, it turns out this got executed first. Why is that? This is a good time to think about what's the order of execution within the node chain, right? You have multiple nodes with the same input handling function that gets executed across the board. How do I figure out what gets executed first, and how do I debug that when that happens? Well, handy dandy documentation right here. You see, this is an example. You can see, probably you can guess what it is. It goes from the bottom, 1, 2, 3, 4, 5, 6, 7. Can you guess what the pattern is from this image alone? Well, I'm going to read the logic here. When sending events to its child and descendant nodes, the viewport will do so as depicted in the following graphics, which is this, in a reverse depth first order, starting with a node at the bottom of the scene tree and ending at the root node. So it's just basically if you expand the whole node tree, it'll just go climb up the tree, basically. Simple enough, right? You think, okay, well, that's simple. So anytime I want to stop the propagation, I just handle it, right? GUI is a little different, right? That is because GUI can interact with mouse event, right? So for example, let me show you what I mean by this. So all of these, I'm going to actually change the size so there's a clickable area. Let's see, transform. Let's call this 100 by 100. We're going to have a control that is, I guess, 100 by 100 as well. So they are on top of each other, right? Let's say we're going to test for mouse event here. So we say if event is action, or event is input mouse event, mouse button event right here. And event is pressed. I'm going to say print name mouse click detected on GUI. And then we'll do that same one for on GUI, meaning this is a signal handler. Bam, right? So if we come over here and then click on the area, what's going to happen? Boop. Only control 2 mouse click has been detected. I didn't consume anything. It's not a mistake. The consumption happens on shortcut, so I can't even get rid of this in case that's the bug, right? So if we come over here and click, only control 2 got the signal and it stopped. Why is that? Well, control itself has a property called mouse, and this is a mouse specific thing. So if I search mouse property on the control, you can see this filter thing. So what this filter does is the behavior of the mouse input, and then depending on this filter, it'll decide to stop the propagation of the mouse event to the layer below, or it's going to ignore, meaning not process it at all, or let it pass through. Okay, so let me draw this out real quick because I think this is a part where visual really helps. Control object, right? This is a control 1, control 2, and then we have node 2D here. And then the click comes from here. Click. So you can imagine very simply if it has mouse filter stop, it's just going to stop it after hitting it. It's like putting a block on it, right? And if you do a pass, it's going to let it through. So you can do, oh, let's do this to be passed, let's do this to be stopped, then the node won't receive anything. If you do pass here, then all 3 of them will detect the mouse click. And if you do ignore, it's going to let it pass, but also it's not going to execute the GUI. Right? Let's do some experiments here again. So if we do, so we know now that it's going to do control 2, control, and node 2D from bottom up. So if we say ignore on control 2, and then say pass on control 1, when we click this object, what do we expect? We expect control 2 to not process the input, control to process the input and print something out, and node 2D will also receive it because control has a pass, right? Click, control, mouse click detected on GUI, mouse click detected on GUI. Well, let's rename some of this. So it'll be input. So one is GUI input function and one is the input handler, right? So that way we know exactly what's happening first. Boop. On GUI happens first, so signal happens first, and then GUI input happens next. On the GUI, right? Because control 2 was ignore. If I do pass, now we're going to get all three of them. Boop. Oh, what the? Oh, weird. Okay. Is this a bug? You see what's happening here? Or is this expected? That is crazy. The control will receive mouse movement input event and mouse button input events if clicked on their GUI input, and control will receive mouse enter, mouse exited signal. If this control does not handle the event, the parent control will be considered, and so on until there is no more parent. Interesting. So the propagation goes to the parent immediately. It doesn't let the other child receive it. Look, you see that? That is intriguing. So if I do pass and then stop here, what's going to happen? Ah, good to know. See, look. See, we're learning. I had an expectation and my expectation was wrong. Even though this was the picture I imagined, it executes it separately. It's stopping the pass-through of the mouse within its chain. That is really unexpected. I feel like that's a bug. Wait, that's not... So that is on GUI input and regular GUI input. That seems wrong. That is a bug. Because, so mind you, for the people who are following here, we're using a 4.3 stable version. So maybe I need to report this because let's change this. Let's change this. I'm going to change one thing. So instead of doing the mouse click on a GUI input, we're going to use mouse entered. Right? Mouse enter triggers, it's a signal that triggers when a mouse pointer enters the area of the object. So I'm going to go around and do one for each one of them here real quick. Oh no, my camera battery died. Ah, oh no. Wait, this is what happens. I need an extra battery pack. This actually happens a lot in my longer tutorials, I have to say. Please share this video with those who you know could use it. Spread the word so I can get more views so I can actually afford to buy more batteries. Good old content creator begging here. Anyways, where were we before the camera battery died? Yes. So mouse entered. So we're just connecting mouse enter. So now we're anticipating this mouse enter to be printed out when the mouse enters. Remember, I made it so that everything is a pass. So I'm going to move the mouse over. Boom. Same thing. Oh my goodness. Let's see. I'm going to do something real quick here. I'm going to add more controls and make it a children of others here. Okay. And then have it all pass. Everybody's going to pass. And then I'm going to connect some of these things. Yeah. That is so interesting. You see what's happening? Everybody's a pass, no matter of the hierarchy. When you pass through the mouse filter in a control setting, it only propagates the pass to its parent. This begs the question. So control is something that has mouse input, mouse entered, and it does some sort of like collision with the mouse, right? But there's also another thing. There is a thing called area 2D. You see in its signal, you see a mouse entered, which is a collision object 2D. So collision object 2D has its own input handling. And guess what? That's actually different because if you look at the document, you see this at the very bottom, a physics picking event. That is what that is, collision object 2D event. So according to this layer, this mouse entered, that is by the area. So this is like any character body, right, with the collision box. This will be the last thing that gets handled with the input. So this mouse entered. So right now, for area 2D, let's handle mouse entered and say print area mouse entered. And of course, area needs a collision box. So I'm going to create a collision shape, 100 by 100 square, like the other ones. What are we expecting here? Boom. Mouse entered for the no 2D. Mouse entered for the control 2. Mouse entered for control 4. Then mouse entered for the area. That seems weird. That is absolutely bonkers to me. Did it just change its order? No. The parent gets executed first. Still, what is going on here? This is so crazy. Hold on. Let me delete the area 2D real quick. I feel like something swapped just now. What is going on here? Whoa. You see what's going on here? The mouse entered goes from parent to children for the controls. And then the mouse click is going from child to parent, ignoring the siblings. Oh my goodness. And as soon as I add the area, which I guess is not that complicated, we expected it to be handled at the end. All right, one more thing. I want to do something else here. What if we have multiple areas, right? Multiple collision body. So let's add one more collision body here. And then obviously layer it on top of each other. We restart this. Boom. Okay. At least this one is working in order, I think. Top to bottom. And well, it's on mouse enter. So let's see if there is a function to consume for the collision. It says array is casted. It'll call the event. Case of 2D scene, conceptually the same happens to input event of collision. So there's mouse entered and there's input event. Let me see what that. Oh, this is so interesting. Input event name. And then we execute it. Boom. Well, it's hard to tell which one happened first unless I looked at first. For input event, 2D first. Yep. So it's going from top to bottom. That's not quite obvious to me why that would be. That seems to be contradictory to what this was saying. That's what the document says, right? It says this order doesn't apply to control GUI input, right? That's what we saw in the experiment. And it says, which uses a different method based on event location or focused control. Oh. Does it have to do with the focus of the control? Interesting. So there is some studies to be done here. I can't tell you what it is right now with this one because it is confusing. But the important part is that you do want to focus on this. You do want to experiment a little bit on this to figure out what is happening in terms of the order. So that's kind of basically all that I wanted to talk about with this tutorial. And, if you don't believe me, if you are curious about more stuff, this is a scaffolding. Like you can see the code, right? To test these things. Try it out and make sure you look at the documentation, you look at the different input names and stuff like that. There is some logic here. You could always tell yourself there you're not going to use anything other than input and unhandled and the process polling. And that's sufficient for the most part. But you do have to be very aware of what you need to do. And all these other input comes in handy to be like, well, it logically makes sense that you would want to handle the GUI elements input first before going for unhandled. But then I know there's a lot of tutorial out there that's like, well, if you're doing the movement, you only want to do the unhandled inputs if you are doing the action commands, right? But that doesn't make sense, right? From the experiment that we just ran, it doesn't make sense. Okay, I obviously started this video to teach you something new, and I had some idea on what the result of the experiment might be from what I knew from my experiences, but obviously it didn't all go as according to the plan, and that's okay. That's the beauty of having to do live experiment. Even after some experience with Godot, and I can say to myself, I know how to use Godot, through experiments, I find something new. And that's kind of showing me that the book knowledge, so to speak, is not sufficient. It's really interesting because time and time again, I keep running across different ways to teach me that nothing teaches me better than getting a hands-on experience, like today's experiment. And that is where Brilliant comes in, today's video's sponsor. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. They use tons of interactivity while building your understanding from the ground up. And what I love about them is that they focus on helping you build problem-solving skills instead of just memorizing some information out there. And if you have been following my content, you know that is the way I like to teach and learn. If you or someone you know have been trying to learn how to program, Brilliant has been growing their programming courses, which are great ways to learn foundations and real-world applications. Develop your mind to think like a programmer, learn essential coding elements, and even get started on Python. To try everything Brilliant has to offer for free for a full 30 days, you can visit brilliant.org/developer-Ezra, or you can scan the QR code right on the screen, or you can click the link in the description. And you'll also get 20% off on your annual premium subscription. Thanks for watching, and thanks for your support.